sketching parabolas by completing the square. We've talked about completing the square before, where we have a quadratic that is not easy to factorize because it's not integer x-intercepts. And what we haven't done is completed the square to get into turning point form and left our answers in exact form, our x-intercepts. So we'll do that. So we've been asked to sketch this, leaving our intercepts in exact form. Since the topic is completing the square, we know we should be completing the square. Another option would, of course, to be using the quadratic formula, which would also get us our intercepts in exact form. If you had time in a test, you could do both in order to check. But you won't. So we're completing the square. We need b, which is -3 over 2 squared, sorry about my pen there, which is 9 on 4. So, y equals x squared minus 3x minus 1 to start with. Completing the square, we're going to insert this. Y equals x squared minus 3x plus 9 on 4 minus 9 on 4 minus 1. If you want the brackets here, to remind you that this is our perfect square, you absolutely may have that. You need to factorize your perfect square, but it's okay because you know that what's in the center here is what goes into your brackets. So this is x minus 3 on 2 squared, and then minus 9 on 4 minus 1, well that's minus 9 on 4 minus 1 on 4, so that's minus 13 on 4. Now we're in turning point form. So we can state our turning point, which is the first thing we need to be sketching. Say whether it's a maximum or a minimum. Because our A is positive, our parabola will be concave up, so it has a minimum. Negative h, remember? So this is at positive 3 over 2, negative 13 on 4, hk. For our y-intercept, you have two options. We know the y-intercept is -1 because it's up here at c. Or, if you preferred, for the y-intercept, let x equal 0, y equals 0 squared minus 3 times 0 minus 1, which is y equals -1. Either of those are perfectly acceptable ways as far as I'm concerned for finding your y-intercept when you're in general form. Having got your y-intercept, you will need your x-intercept, plural. X-intercepts, let y equals 0. 0 equals x minus 3 on 2 squared minus 13 on 4. Remember, this is a difference of perfect squares. You know you're aiming for exact values, so there's going to be surd form over here. This is a square. This can be made into a square. If you want to do this line of working, you are welcome to. I'll just switch colors. Remembering that this is 0 equals x minus 3 over 2 squared minus the square root of 13 on 4 squared. We can simplify this because that's the square root of 4 and the square root of 13, and the square root of 4 is 2. This isn't necessary as a line of working if you don't want to. So what is necessary is your 2 brackets, because you're getting a difference of perfect squares. The first term's square root is x minus 3 on 2. That goes at the start of each bracket. Plus and minus. The second term's square root is the square root of 13 over 2. Because remember, square root of 4 is 2. Root 13 on 2. So our x-intercepts, again, from here, I don't need to see you explicitly working through the null factor law. If you wanted to, x minus 3 on 2 plus root 13 on 2 equals 0, or x minus 3 on 2 minus root 13 on 2 equals 0. At this point, I'd really be doing your plus minus rather than doing them separately anyway. And of course, you'd rearrange. So this is x equals, add 3 on 2 to both sides. And notice these are both over 2, so it can end up as all over 2. So, oh, sorry. I got, yep, no, I'm good. I thought I had a, that's minus. I thought I had a minus in the wrong spot. So I'm taking away root 13 on 2. There. Or x equals, again, this is all over 2. 3 minus, so add this to both sides, plus root 13 on 2. Sorry about that. And again, you could have just given that as x equals 3 plus or minus root 13 on 2. That's fine as well. Then to sketch it, we now have all the information. It's a good idea to work out roughly where these would be. So, on the square root of 13 is 3.6, approximately. So 3 minus 3.6 is going to be giving me negative 0.6 on 2, so negative 0.3-ish. And 3 plus 3.6, so this is 3-ish. So just work out roughly where it would be on your number line so that you don't sketch your parabola completely wrong. So, draw yourself up a set of axes. Remembering that you can plot your points and then put your parabola in, or you can get your parabola roughly in the right spot. And then put all your points in, so you're not trying to squeeze your sketching in. So, our y-intercept was -1. Our turning point at that 1.5, -13 over 4. And our x-intercepts, 3 minus root 13 on 2, 3 plus root 13 on 2. Label x and y, label your parabola. And that is sketching a parabola by completing the square, leaving your x-intercepts in exact form.